Hi, so in this chapter, we'll add to what we've already done with our refactoring and add the ability to move our motors again. Our goal is to take the code that we have from last week and make slight changes to it so that we can control our motors. We'll start by just doing a little bit of code cleanup. And when we have functionality that should exist for multiple programs, so let's say we want a program that controls our motors just to test that the motors work, but we want a second program that is testing to see if we can communicate with the display. Maybe both of those are going to rely on our WebSocket code. What we don't want to have to do is copy and paste our files everywhere. Currently, I have our WebSocket heartbeat code and our WebSocket heartbeat refactored. Inside the refactored directory, that's currently where our WebSocket communicator.h file exists. That's not a great place for it because we want to be able to access it from multiple programs that we want to run separately on our microcontroller. So it's pretty standard to create a directory called include. So I'll create a new directory called include, and since this is demo code, I'm just going to copy our file over. Instead of moving it, I want to leave the WebSocket heartbeat refactor code exactly as it is, and it requires this WebSocket communicator to exist right next to it. So instead I'll just make a copy of it and put that in include, and that'll be our sort of finalized version that we'll make changes to throughout the semester as we need to. We are not going to copy over our LED blinker code because that's not really functionality we need to keep using. That was really just a demo. So the next thing we'll do is create a directory for our new program here. We'll call it motor control. And maybe what I should really do is create a set of demo files. These aren't our main program that we're going to run when we have our robot driving around a course. They're really just small test files. So let's call those examples like I did inside the twait code. And inside examples, let's create a simple motor control example. And I think it's really going to be beneficial just to start with using this LED blinking code as our template to start with. So let's copy that directly over. That's our WebSocket heartbeat refactored INO file, our Arduino file. And let's copy that into examples, motor control, and let's rename it to motor control.ino. Okay, we now, since we've moved files around, the WebSocket communicator code is not right next to this one anymore. And we don't need the LED blinker, so I'll start by just deleting that. We'll also delete it from here. We don't need it here. And we don't need it here. We now need to tell the compiler where it can find WS Communicator. And this is not just a problem inside VS Code. So for instance, if I were to open that file, on Mac, if I just call open, it'll use the default programming for opening INO files, which should be the Arduino IDE. So if I open this file and try to compile it, first it's going to complain that I haven't told it what kind of board to compile it for. And since I don't have one plugged in, it has no clue on what to do. Selecting the board, even if one's not plugged in, does allow me to compile it. What I'm expecting here is an error where it can't find this WebSocket communicator.h file, just like we were getting in VS Code. Instead of telling the compiler that it's in the, or the linter in this case, that it's in the exact same directory, I can give a relative path to where it can find this file, the WebSocket communicator file, from the current motorcontrol.ino file. So looking at all of our code, let me change directory into that example. This is where motor control INO is. So I need to go up one directory. That puts me in the examples directory. Up another directory. So // And then from there, the file I'm looking for is inside include. And and giving the linter just a little bit of time, it now picks up that that's where the file exists, and the rest of the file now shows no problems. Popping back over to the Arduino IDE, it's also able to find the relative include. It's a relative include because it's done here in quotes, and tell me a little bit about the program that it compiled. Now if I were to try to upload, it would say, well, it tries to compile first, and then if I check back on this in a few seconds after compilation, it'll tell me there's no board connected and it didn't know what I meant by upload. So after compiling, here's the error message. Could not detect the port after the upload, which is perfectly reasonable because I've not plugged in a board and I haven't told it what board to even look for. Before jumping into adding our code to this repository, now that I'm no longer using the TOIT code, no longer has a README. Which means if I were to go to the web page for it, you would notice it's complaining here about no README, no documentation for it. So this would be a good time to add just a little bit of information to that README. And I'll come back and clean this up a little bit more after this video. But I do want to take this time to show you a couple of useful things to put inside the README. One actually would be installation. We'll come back to that. But another useful thing to have inside your README is a little bit about the directory structure. So this will be a note to everybody when they come back and when you all come back to this code and want to know what to find and where to find it. So inside here, I always like to put like a tree view of the file directory. And I have a nice program on my computer called, let's see, I don't remember off the top of my head, but if I ask, it's called EZA, and that program will spit out a nice tree view of all of my files. My VS Code window doesn't have certain symbols for the font, but if I do the same thing using a different terminal with a font with those symbols installed, oh, I shouldn't have done that from my home directory. That's going to be a lot of files that it's trying to open. If I do the same thing from my like the terminal that's not inside VS Code, I have a nicer font installed, and it gives me nice little icons for files and package lock and configuration files. So one thing I can do is take the output of that and pipe it into my clipboard, which means I can now paste it into here. And a lot of this is stuff that I don't really care about. I probably should have limited the output and ignored certain files. But I will do that manually. Everything inside TOIT can go away for now. We do care about the examples, although I'm not going to add any documentation on the specific examples or the specific include files. And now that I think about it, this WS Heartbeat really should exist inside examples, as should WS Heartbeat Refactored. And I want to make sure I take this nice pipe symbol here and paste it there. This is really all I care about leaving inside the README. So now I can add some documentation. And I'll do that after the video. No need to spend valuable video time explaining what I'm already going to put in text for you. Now that I have our WS Communicator header file, let's open that up. Did I open up the right one? No, I opened up the one that's inside the refactored directory. I want the one that's listed here as being inside the include directory. One thing I neglected to do, just because I didn't want to throw too much at everybody all at once, was I neglected to put something very important at the top. This really won't come up much this semester, but at the top of your header files, you need what are called header guards. And one way to do that is to add this pragma once directive at the top. That does require compiler support for that particular configuration. An older way to do this, which works pretty much everywhere and is still pretty standard if you were to look at any header files, is to do what's called the header guard with an include. So we're going to say that if somebody has not already included this header file, then you can go ahead and include the header file. So if not defined, and then what you do most of the time is just turn the file name into something that should be unique to just this file. So WS Communicator _H sort of indicates the name of the file in a standard format. This define shouldn't really show up anywhere else in code. So if nobody's already defined that, then you can do the rest of this. And I need to put an end if at the very bottom here. So who actually defines WS Communicator.h? Actually, we do. So if it's not already defined, then you can include the rest of this, which includes that definition. So this ensures if I include WS Communicator in multiple other files, it really only gets included once, which means it won't confuse the compiler. It won't say there are multiple definitions, for example, for WebSocket heartbeat state. So that's sort of your minimum setup for any header file, is to have that if not defined, define, and end if wrapping the entire file. I bring that up because we're immediately going to create a new include. So inside of our includes, we currently just have WS Communicator. Let's create a new file inside includes. And let's call it the motor control header file. So we'll start this in that same way. If not defined. I was hoping Copilot would automatically pick up what I want there. So if it's not defined, we'll define it. And then we'll wrap this, basically a big, large if block. And I suppose that's fair. My spell check is telling me that it would really like motor and control to be separated by spaces. They're two separate words. The last thing I want to do in this first video is just get this started. And by get it started, I mean, what do we want to do for any new piece of functionality we have? Well, we'll define our motor. So we'll have our globally defined object. We'll call setup on it. And we'll call loop step on it. So that'll be the sequence of events that we do over and over again. Include, call the constructor, call setup for more complicated setup, for example, things that might fail and that you'd want to have some interaction with the serial interface for debugging, and then call step on it inside the loop. And just like our LED blinker, this loop function is likely going to want to know if we're enabled. So that's where we'll end this one. In the next video, we'll start implementing our motor controller.